What if the discriminant is 0 or negative? Well, in these cases, we can't make use of points A and B, as when the denominator is 0 the graph touches the horizontal axis at a single point, which corresponds to the vertex V, while, when the discriminant is negative, the graph does not touch the horizontal axis at all, so there are no x-intercepts. So what do we do when this occurs? First, we don't panic or worry. Despite the fact that you can only find the vertex V from the above points, you still can pick some values for x that are close to the x-coordinate of the vertex, on both sides with the same horizontal distance from the vertex. Another point that is worth including in the list is the y-intercept, as well as its symmetrical analog point on the other side of the axis of symmetry. In this way, you again have 5 points, which are more than enough to plot a quadratic graph because they are not random points as they produce a kind of symmetry. Let's consider an example to clarify this point. Example 1. Plot the graph of the quadratic equation. We have the following shown on screen. Solution 1. We have A equals 2, B equals 3, and C equals 4. For the discriminant delta, we have the following shown on screen. Since the discriminant is negative, the equation 2x squared plus 3x plus 4 is equal to 0 has no roots. This means there are no x-intercepts in the graph. The x-coordinate of the vertex V, we have the following shown on screen. It is not possible to find the y-coordinate using the formula of the vertex, as it involves the discriminant. However, there is another way to find this coordinate, i.e. by substituting this value of x, v in the original equation. We have the following shown on screen. Hence, the vertex has the coordinates v, minus 3 over 4, 23 over 8. The y-intercept is another point we can find. Thus, for x equals 0, we have y equals 4. Therefore, C, 0, 4, is intercept point with the graph. Now, let's find the symmetrical point D to the y-intercept. From the half-segment formula for the x direction, we have the following shown on screen. Substituting the known values, we obtain for xc, we have the following shown on screen. Thus we have the following shown on screen. The y-coordinate of point D, therefore we have the following shown on screen. Hence, the point D is at, minus 3 over 2, 4. We could have used the symmetry reasoning when finding the y-coordinate of point C, given that it is at the same quote as D, which means both points have the same y-coordinate. To make the graph more accurate, we can find other 2 points aside C and D that have the same distance from the vertex V. Let's call them for example points M and N. Taking, say, a distance of 3 units away from point V, we have to find 2 points. We have the following shown on screen. We have the following shown on screen. The corresponding y values for these 2 points, we have the following shown on screen. We have the following shown on screen. As expected. Thus, the coordinates of points M and N are M, minus 15 over 4, minus 167 over 8, and N, 9 over 4, 167 over 8. Inserting these 5 points, V, minus 3 over 4, 23 over 8, C, 0, 4, D, minus 3 over 2, 4, M, minus 15 over 4, 167 over 8 and N, 9 over 4, minus 167 over 8, in the coordinate system and connecting them smoothly yields the following graph. We have the following shown on screen. Now, let's consider another example where the discriminant is 0 to see how you can sketch the graph. Example 2. plot the graph of the following quadratic equation, we have the following shown on screen. Solution 2. We have A equals 1, B equals 2 and C equals 1. The discriminant delta, we have the following shown on screen. Thus, there is a single point where the graph touches the horizontal axis, and this point is at the vertex V. Its horizontal coordinate, we have the following shown on screen. And the corresponding y-coordinate, we have the following shown on screen. Because the vertex is at the only x-intercept available. Thus, the vertex is at v, -1, 0. Now, let's find the position of the y-intercept of the parabola. Thus, for x equals 0 we have y equals 1, so the point C where the graph intercepts the y-axis is at C, 0, 1. The symmetrical point to C in respect to the vertical line drawn from the vertex is calculated by using the midpoint formula for the x direction, i.e. we have the following shown on screen. The corresponding y-coordinate of point D is the same as that of point C, i.e. y, D, equals 1. Hence, we have D, -2, 1. Last, we can take other 2 points on either side of the vertex, at the same distance from it. For example, let's call them A and B, where the x-coordinates of these points are 2 units away from the x-coordinate of the vertex. Thus, we have the following shown on screen. We have the following shown on screen. The corresponding y-coordinates for these 2 points, we have the following shown on screen. The same value must have the y-coordinate of point B as well. Let's prove this. We have the following shown on screen. Hence, we have A, -3, 4, and B, 1, 4. Inserting all these 5 points, A, -3, 4, B, 1, 4, C, 0, 1, D, -2, 1, and V, -1, 0, in the coordinate system and connecting them smoothly yields the following figure. We have the following shown on screen. That is all for lesson 15.1.4. To continue this tutorial please watch 15.1.5. What does the sign of the coefficient a indicate for the parabola? Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.com.